Hi everyone, this is Sugantha Priya, Assistant Professor, Department of Computer Science, Dr.S.N.S. Rajlakshmi College of Arts and Science. This presentation is about memory management in operating systems. What is virtual memory? Virtual memory is a storage scheme that provides a user with the illusion of having a very big memory. This is done by treating a part of the secondary memory as a main memory. Virtual memory is a storage allocation scheme in which the secondary memory can be addressed as though it were the part of the main memory. In virtual memory, the user can store processes with a bigger size than available main memory. Therefore, instead of loading one process in the main memory, the OS loads various parts of more than one process in the main memory. Virtual memory can be implemented through demand paging and demand segmentation. This is an example of virtual memory. For example, let us assume that an operating system requires 300 MB of memory to store all the running programs. However, there is currently only 50 MB of available physical memory stored on the RAM. The OS will now set up 250 MB of the virtual memory and uses a program called as a virtual memory manager to manage the 250 MB. So in this case, the VMM will create a file on the hard disk that is 250 MB in size to store the extra amount that is required. The OS will now proceed to address the memory as it considers 300 MB of the real memory stored in the RAM, even only 50 MB space is available. It is a job of the virtual memory manager to manage the 300 MB memory even if just 50 MB of the real memory space is available. Next is paging. In operating systems, paging is a storage mechanism which is used to retrieve process from the secondary storage into the main memory in the form of pages. The main idea behind the paging is to divide each process in the form of pages. The main memory will be divided in the form of frames. So if you see in this example, we have different frames numbered from frame 1 to frame 9 in the main memory, whereas the process is divided into equal sized pages starting from page 1 to page 9. Next is paging. Let us consider the main memory size 16 KB and frame size is 1 KB. Therefore, the main memory will be divided into a collection of 16 frames of each 1 KB each. There are 4 processes in the system, that is P1, P2, P3 and P4, which is of 4 KB each. Each process is divided into pages 1 KB each so that one page can be stored in one frame. So there are 4 different processes in this example. So each frame size is 1 KB and the frame size is equal to the page size. So all the process fits into the frames, that is 16 KB. So this is a paging hardware. So we have a CPU. So the address that is generated by the CPU is called as a logical address, so which contains the P and D. So where P is a page table, so and D is the physical address which is mapped with the physical memory. Next is a page table. So a page table is used by a virtual memory system in a computer operating system to store the mapping between the virtual address and the physical addresses. Thus a page table mainly provide the corresponding frame number, base address of the frame and where that particular page is stored in the memory. A page table contains all the entries about a particular page. If you see in this example, in the logical memory we have different pages like page 1, page 2, page 3 and page 4, whereas in the page table, so we have the page numbers, whereas in the physical memory, so the page is fitted into the physical memory. Next is the page replacement algorithm. In the operating system that uses for paging for memory management, a page replacement algorithm is need to decide which page needs to be replaced when a new page comes in. Page fault. A page fault happens when a running program accesses a main memory page that is mapped into the virtual address space but not loaded in the physical memory. In case of page fault, the operating system might have to replace one of the existing pages with the newly added pages. Next is the FIFO page replacement algorithm. This is the simplest form of algorithm. In this algorithm, the operating system keeps tracks of all the pages in the memory in a queue. The oldest page in the front of the queue is removed first. When the page needs to be replaced again in front of the queue is selected for the removal. So consider a page reference string 1, 3, 0, 3, 5, 6. with 3 page frames, we have to find the number of page faults. In this algorithm, pages are replaced which would not be used for the longest duration of time in the future. Example, consider the page reference 7, 0, 1, 2, 0, 3, 4, 2, 3, 0, 2. With the 4 page frame, we have to find the number of page fault. So number of page frame is 4. So we have the total page fault, it is 6. So we have to find the number of miss and hit in this particular example in order to replace a particular page. Next is the least recently used page replacement algorithm. In this algorithm, the page will be replaced with the least recently used. So we have the page reference string 7, 0, 1, 2, 0, 3, 0, 4, 2, 3, 0, 3, 2. With 4 page frames, we have to find the number of page faults. So the number of page faults, it is 6. So initially all pages are fitted into the frame. So if the page is already present, then it is called as a hit. If the page is not present, it is called as a miss. Next is the not recently used page replacement algorithm. It favors keeping pages in the memory that have been recently used. The OS divides the pages into 4 classes based on the usage duration. Last clock tick, that is reference modified, reference not modified, not reference modified, and not reference not modified. Thank you.